welcome back to another Unity tutorial. In this one we're going to be going into doing knockback in 3D space, and obviously you can easily do it in 2D space, but I'm going to be showing in 3D space. So we'll have it so a projectile can hit something and knock it back, and then we can also make it so that rather than just calculating the direction where we hit it, we can maybe force a knock up, like if you've got a spell that knocks up. Or you could even have it so it's like an AoE, so it, when it collides with anything, it gets all of the rigid bodies around it and knocks them away from that position rather than just the thing you hit. But yeah, we'll get into that. Thanks to my Patreons, thanks to Paul Robinson, Fullbomb and Wesley, and this time special thanks to Michael for his $50 donation, very, very generous. If anyone else wants to help donate, then the link's in the description below. Apart from that, let's get into it. So, I'm using one of my projects from a while back because it's kind of like a follow-on, so if you've seen... well, if you haven't seen the component-based architecture video or component-based design, whatever I called it, go back and watch that first. I'd highly recommend. But if you have seen it and you just want to carry on here, then let's go. So last time what we did was we made it so we had generic scripts. It was more of a video showing best practices. So we'll have a projectile prefab that we shoot, and we can add whatever scripts we want. So we've written destroy on collision, damage on collision, and particles on collision to make this projectile. The reason why this is better than hard coding a script to do all three is because some spells or some projectiles you have might only do one of those things, some might do two, some might, this, that, the other. You want to be able to easily switch out, and it's bad to like write all the code in one script and then just have like booleans to say, yeah, do this, don't do that. It's easier just to have separate scripts and you attach what you need. So we're going to turn that, we're going to build on this and add some more, basically. So if we're going to be doing knockback, rather than having these like objects stuck in the air, we're going to make them on the ground. So let's just create a ground plane. I mean, I'm using a cube, but we'll go for like 50 by 50. Make sure it's got some depth, and we'll just move this cube and capsule thing up a little bit. So we're at 1, but the capsule guy needs a bit taller. Okay, now let's just. I want to create material for this floor, otherwise it'll be really hard to see. So we'll just make this like darker, I guess. I don't like the shine on it. There we go. Alright, so if we bring the camera up so we can get a good view of this, it'd be better. Alright, so what do we want to do? Well, we want to make it so this green guy can shoot a projectile like he does currently. I think now that I've moved them though, the projectile might go over the enemy. No, it still hits. Alright, it's fine. We'll just leave it like that. So we want to be able to fire a projectile, and when it hits back in that direction, and then we can try moving it around and attacking from different directions. So we need to write a new script for this projectile, basically. So if we go and just create a new C# script called knockback on collision, like so. So let it load. And we can actually, just for the sake of demonstration, I'll also open up, for example, destroying collision. Now, as you said, I could make destroying collision. You could actually reduce this to like 4 lines long. You could get this into 1 line. This whole thing here. I mean, you could do the whole thing in 1 line, but it's nice to have it. But if you look on here, what do we want? Well, it's basically the same. We just want something which gets called on collision enter. Wait, did I just do that? Or did that just fit? Oh no, wait, that is already like that in 1 line. Because do is we're going to say on collision enter. On collision enter. How do we want to do? The thing we're colliding with actually has a rigid body, otherwise there's just no point doing anything. So what we can say is we can say rigid body RB is equal to collision, so the thing we've collided with. Collision dot get component. So, alright, collision, sorry, is just data, like information on a collision. If you want to get the thing you collided with, you do collision.collider. That's the actual object we hit. So this is the data of the collision. This is the thing we hit. Obviously, there's other data on the collision. Let's see what else there is, just for demonstration. You've got the collider, the points of contact, friction, I don't know, there's other things. But we can say collision.collider. Dot get component. Now we can try and find a rigid body script on it. So if the thing does have a rigid body, it'll store it here. If it doesn't, then this will become null. And if it's null, we can do a check. So we can say if RB does not equal null, so does not equal null. Basically, if the thing does have a rigid body, what do we want to do? Well, if the thing has a rigid body, we want to calculate the direction between this object that we're firing off, and then that we've hit. So the way we do that is we need to say, if you haven't done vector math before, it shouldn't be too hard to grasp, but basically, so vector 3 is, X, Y, and Z in the scene. So if we know the thing we've hit collision, the position, so collision dot collider dot transform dot position. So that's the thing we hit, right? Can we actually just do collision dot transform? I don't think we can. The transform the object we hit. Oh, it does work. Okay. Collision dot transform dot position. Okay. Minus transform dot position, which basically says we're gonna take. We have to actually set it somewhere. We can't just say that. But I'll get rid of that. Get the vector 3 of the the vector 3 position of the thing we hit. Subtract our vector 3 position, and that gives you a between the two. So if we just store that, so we can say vector 3 direction is equal to that. Then we can say, depending on if you want, you could say direction dot y is equal to 0, because sometimes when you do knockback, you don't want it to knock up or down direction. So it's up to you to add this line. If you want it to go horizontally, then just leave direction dot y equals 0. But for the sake of this, let's leave that in. I don't know why I spammed undo there. We want to take this. What's going to happen is vector 3s have magnitude and direction. So obviously direction indicates where it is. Magnitude is how far away it is. So the further away it is, the higher the magnitude. Now, with your knockback, you don't want the knockback strength to be changed by the how far away something is. Now, you might do that, but most of the time you don't. You want a set knockback strength. So let's make it so we can have a knockback strength. So knockback strength. Oh, I need to say private float, if I can spell it right. And then what we want to do is we want to say RB, so the rigid body that we've basically found, the enemy's rigid body, add force. There we go. It's a function that takes in the direction it wishes to add a force in. So we'll say direction. But the thing is, because direction, as I said, is influenced by how far away it is, we want to say dot normalized. And as you see here, it returns the vector with a magnitude of 1. So basically, it will still have the same direction, but its magnitude will be 1. So no matter, we're going to have the same strength. And the benefit is that once we've done this, we can multiply this by a float, which is knockback strength. If you multiply a vector by a float, you keep the vector, and the x, y, and z all get times by this, basically. So if it was like, if the direction was, point, well, I know it's going to be normalized, but let's just say it was a, 10, 10, 10 in like x, y, z, then this knockback strength was 10, then it would be 100, 100, 100. You get that. Obviously with different numbers it would be different, but if we didn't have this knockback strength, then it would knock back, but it would always just be, a little bit in that direction. So this lets us tweak how much power to add. And then you can add a force mode. Now, sometimes people to leave this blank. I like doing force mode dot impulse on this kind of thing, because force mode dot impulse is generally used for, well, as you see here, it uses the mass to add an impulse. So it's kind of like a single hit, and it takes mass into consideration. So if your enemy has a larger mass, then it's not going to actually knock them as far, which makes sense. I think you can do dot velocity change if you want it. Yeah, so if you want to add an instant thing, but you don't care about the mass, like even if you had like a big guy and you wanted to knock him just as far, then you would do that, but you want to probably stick with impulse. And now that we've done that, we can actually go and test it. But first, actually, for this to work, as we've checked in the code, we make sure before we try and add force to a rigid body that the enemy has a Let's just go rename this so it's easier to see. Enemy and player and floor. So go get the enemy, and we're going to give knockback. And if we go to the projectile, let's say, we'll just add the knockback on collision. There's nothing else we really need to do. Now let's just say, 10 might be a lot. Let's just do 2, and then we can tweak it. So let's shoot this, and it should do a knockback of 2. Well, there you go. Now, I should have just played again. I can change the strength from runtime. So let's say we go for 5. it should knock it a bit further. Well, as you saw there, it knocked it a bit further. Now, just to show that this is actually working, we'll shoot, go to scene view, and I've put 100. So, yep, there it goes, flying off into the distance. So, that does work, basically. It adds it off in the direction. Now, that's nice and all, right? You want to hit something in a direction. But let's say, and that's like the main part of the video, right? Showing how to do directional knockback. So, if we hit it from the other side, it would go this way, and so on. One other thing you might want to do, let's say you had a script that added like, I'm not going to bother making new scripts for this, so let's just alter this one. So let's say we wanted to make it, when we hit it, pull it towards us, right? We want to add a force towards you. You can actually do a minus there. So rather than, when we get the direction between us and the thing, we might not want to knock it away, we might want to knock it towards us. I don't know why, maybe. Now if you want to move a set distance, then you wouldn't use force, but the point is you can. So yeah, I had it on 200 still. But the point is you can actually tweak this projectile thing. Let's change it from a knockback strength to a 10. And we'll go hit the guy, and it should knock it towards us quite far, or like, you know, decent amount. So there you go, you can knock stuff towards you. Now, just because of like friction and, you know, slight offset on hitting, it appears to have knocked it that way a little bit. It doesn't really matter. You know, the whole point of the physics system is it's never exact. That's why you use physics to be realistic, not exact. Now, either that or like the vectors just aren't exactly set. Like, these guys might not be in a straight line. They probably are, but I don't know. It doesn't matter. I'm not fussed about that. Now, obviously, so I don't forget, I'm going to not have that as a negative, but you can just have one as negative. You could do perhaps an AoE one. So I guess we'll end off on that. Yeah. So I'm going over the place. So if we duplicate this enemy, put one there, put one there, put one there, put one here, for example, or maybe I want to go like, I want them all to hit basically. So I don't know. You get the idea. All right, so we've got these like clumps, this clump of enemies, and we want to basically fire here and knock them all out. Now the problem is, right how it is currently, this will just add a force to the thing that we hit, so all these guys don't get affected. So maybe you want to have a script for like area knockback on collision. Okay, area knockback on collision. We'll take this knockback on collision and we'll just alter it a bit. So, make sure you rename the script, so area knockback on collision. Make sure you rename the class name. Get rid of these extra using statements that you don't need. The shortcut for that is Control-K, Control-D. If you do it for the first time, it might ask you some little settings thing to tweak for your preferences, but yeah, once you've done it, it's just Control-K, Control a bit. It's quite is rather than saying, what we want to do is you know what, actually we'll just scrap this. We'll just take the on collision enter. We don't let's say it on a little area. So there is this thing called rb.addExplosive So what you want to do is you want to you want to get all colliders in a particular radius, which is obviously up to you. Then you want to knock back each one, so you would loop through that list, calculating the direction to knock back, and then you would times it by the force. Sorry, I'm getting a bit confused now. So yeah, we're going to have this knockback strength, then we're going to have a float for like knockback radius. What we need to do is we need to get the list of things to knock back. So what we need to do is we need to of colliders, because what we can do is we can do this thing called overlap sphere. So if we have a collider, whoops, we need to be capital C because it's the class name. So collider array, so it's like the little open and close square brackets for an array, called it colliders. And it's equal to physics.overlap sphere. Now what that does is, just like a raycast shoots off a ray, an invisible ray, and then gets back what it hits, overlap sphere will do an invisible sphere, and everything inside that sphere will be returned into this list of colliders. And overlap sphere takes in, it's not going to tell me yet. So a vector-free position, so transform.position, you know, we're going to do the sphere from our position, the projectile's position when it collides. And we want to go for knockback radius, because that's like how far out we want to go from here. And it's going to return everything in that radius from the transform into this list of colliders. And then once we've done that, we can basically go through each collider in there. So for each collider object, in colliders. Oh, what have I done? I didn't give it a name. Oh wait, object is already a used thing, so I can't use object. For each collider enemy. I know they're not all enemies, it's technically any physics thing. It doesn't matter. Name this whatever you want. Just keep it a variable, you know, variable name. Sometimes programmers get too caught up on variable names, and I definitely do. But anyway, so for each collider enemy in colliders, so for everything in this list, we can then say, you could also just use a for I loop. You could say for I is less than colliders, whatever. I mean, yeah, people are probably more used to that. I'll stick to that. So for I is less than colliders dot length. What we want to do is we want to say rigid body RB is equal to colliders I dot get component rigid body. Right, so we're going to loop through this list of everything in the area, and we're going to get each the rigid body of each one in turn. So we're going to go for the first thing in the list that we've collided with, get its rigid body, and just like before, if it has one, then we can do it. Otherwise, we can't. So we need to say if RB does not equal null, and if it doesn't equal null, what did we do? Well, we basically calculated the direction of that thing and added the force. Well, explosive force is a function on rigid body, so RB.explosive force. And what that basically means is you don't have to calculate the direction, you just tell it where this thing is and the radius, which is what we've already basically established. And then we pass in the force as well, so like how strong it is. So all we need to do is we need to pass in explosion force, which you've called, you know, knockback strength, so knockback strength. We need to pass in the position, so transform.position. The radius, which is knockback radius. Whoops, knockback radius. And then it takes in another parameter, which you can see, which is upwards. What have they called it? Upwards modifier, which actually wait. No wait, that's fine. We don't need to add that one. It says, as it says here, this is adjustment to the position of the explosion to make it lift objects. We don't actually want that. So we can just leave it like this, right? We've used our strength, our current position, and the radius to make sure it actually like will knock it back. And then all we need to do now is save it and test it. So, whoops, I did not mean to do that. Control K, Control D, indentation. So as you see, it's like the same as this. It's just getting a list and looping through them. So now, if we do this, we're just going to need to go back, go to our projectile, remove this knockback on collision, and we're going to add a area knockback on collision script to this projectile. Knockback strength, 5 will do. Knockback radius, 5, it doesn't matter. Just make sure you get all these objects in it. And then now, when we click, it should. Maybe 5 wasn't big enough. Did I not add rigid bodies to these guys? I did. That's peculiar. Let me just try again. So, projectile, knockback radius, 100, 100, and then this is 10. I know 100 is like gigantic, but maybe I just missed something off. I'm not sure actually. I might have to go check the code. That's interesting. Alright, so what we can actually do then is go back to the code. Let's debug this. So, I don't know how you get this bookmark. I accidentally must have put on. I'll do that later. So let's do a thing here. So press debug and then run the game. let it compile. Alright, oh, I fired 2, oh well. So, it's hit, and we've got a list, so let's go to the next line. This list of colliders, we've collided with 8 things. Alright, RB is colliders, I.getRigidBody, if it's not null. Add the force, add the force, add the force. Okay, so that's interesting because wait a second, I think I know why. It's probably because it's not like force mode dot impulse. So upwards modifier 0 force mode dot impulse. Okay. Yeah, that might be it, to be honest. So is that compiled? I think it has. Let's just try that again. Let's push this one forwards. Whoops, that was in play mode anyway. So if we go back to the projectile and maybe tone it down a bit now, knockback radius 10. It should, hopefully, fingers crossed. There we go. Okay, it was just because I think it would have worked if I'd ramped up the strength, but when you don't have impulse, it seems to take a lot more force to actually knock something back. But the point is, it worked now. It actually knocked everything back in a radius around it. So yeah, this video took a little bit longer. Obviously, it was only a short little debug. It's like 1 or 2, like 1 minute. But yeah, I hope this video answered anyone's questions if they were struggling with this kind of thing. I hope you understand how to implement this, and just showing how good this system is with the destroy on collision, damage on collision, particles, area knockback. You can just make your own custom things depending on whatever you want on them. You can also add those scripts in at runtime. So if you add like augmented projectiles where like maybe the player would click a button and they've now made the spell do 3 at once or something, you could just add a component in script. You could say you know, area knockback on collision, you know, so on. So yeah, I hope you found this video useful. If you haven't already, please like and subscribe.